So now we'll turn our attention to module 5.2, which is molarity and solubility. In a solution, you always have a solvent and a solute, and a solution is a homogeneous mixture, which means you only see one thing, a uniform composition. So for instance, alcohol, you only see one thing as an example of a solution. But within that solution, as I said, you have a solvent, which is much more abundant than the solute. And as I mentioned earlier as well, when water is a solvent, you have this aqueous solution where you can designate the compound being AQ, aqueous. We talked about solids, liquids, and gases. Aqueous is another as well. So molarity. One way to measure molarity or concentration is we talked about ppm, parts per million, and parts per billion in a previous module. Molarity is another way to do this, which is big M, moles divided by volume, and the volume should be in liters. So we can say big M as the unit, or we can put brackets or parentheses around it to indicate the concentration. So concentration, which is analogous to molarity, is big M units or moles per liter. So an example of a calculation, how many grams of NaCl are in 1 liter of 2 molar NaCl, sodium chloride? Just a brief review, we had a roadmap, if you recall. We had moles and mass. We multiply by molar mass, or we can divide by molar mass to go from mass to moles. We also had molecules. If we went from moles to molecules, we multiply by Avogadro's number. And if we divide by Avogadro's number, we go from molecules to moles. Well, now we can add to this roadmap. And if we had molarity here, if we went from moles to molarity, we would divide by the volume. And if we go from molarity to moles, we multiply by volume. And this comes from the previous slide where big M molarity is moles divided by volume, which should be in units of liters. So in this problem, they're asking how many grams are in 1 liter of 2 molar NaCl. So they give us the concentration, 2 molar. We know the volume. We can go from molarity to moles by multiplying by the volume, which they did right here. And once you have the moles, you can multiply by the molar mass to get to the mass. Remember, if you hear the word molar mass, you need a periodic table in front of you. So we got this molar mass from the periodic table. Sodium is about 22.98, 23 is fine, and chloride is 35.45. So when you add those two up, you get the 58.44. So when you do this math, 2 times 58.44, you get 106.9 grams of sodium chloride. In the lab, if you want to prepare a solution with specific concentration, one way to do it is to use a volumetric flask here on the right side. And you simply add the mass of interest. So let's say we wanted to add 58.5 grams of NaCl. You put that in your flask. You add 1,000 milliliters of water to line up to this mark here. This mark is very specific. It tells us exactly 1 liter of solution. So once you put the 58.5 grams of NaCl, you top it up with water, you've made a solution of 1 molar NaCl. Some exercises to try. You can pause the video if you want. We'll go through it now. The question is asking us, which solution is more concentrated? this 0.05 moles of 250 milliliters of solution, NaCl, or a second solution, we'll do it in green here, of 0.6 moles over 200 milliliters. So if we do the calculation, 0.6 moles over 0.20 liters, remember our units, versus 0.5 moles divided by 0.250 liters. Remember, converting from milliliters to liters, you divide by 1,000. I'll let you do the math to figure out which one will be higher. Will it be the solution in red or the solution in green? I'll let you guys figure that one out. And the next question below, they're asking us, a student is asked to prepare 1.0 liters of 2 molar CuSO4. The student has filled it up with 40.0 grams of CuSO4, copper 2 sulfate, and asking us what is the resulting solution. Is it 2.0 molar? So I'll walk you through the steps. First, you go from mass to moles. So you'll divide by the molar mass, as our roadmap says. So the molar mass of copper sulfate, 48 for the O, 16 times 4, plus 32 for the sulfur. And the periodic table for copper, 63.54. We get a molar mass of 143.5 grams of CuSO4. So once you have the moles, you multiply, or sorry, you will divide by the volume, which is 1 liter. And I'll let you decide if it's greater or less than 2.0 molar when you do this math.